Okay, we're supposed to solve a triangle given following measurements. We'll make the assumption that we're using the standard idea that the angles are labeled with capital letters A, B, and C, and that the sides opposite those angles are used with the corresponding lowercase letters. So if angle A is 25, side A is represented with the lowercase a is 77. Now, how do you know that there's two triangles? There's a couple ways to do it, but the standard way in most textbooks is to find the length of this altitude right here. Notice how what I first did is set up a 25-degree angle, then drop an altitude from the end point of side AC. That's a perpendicular. And so the sine of 25 equals h over b. And we can find out here that in that case, h has a height of 45, 46. And the side opposite, 77, is greater than 46, but less than 108. So if we picture that black dashed segment on a hinge swinging back and forth, it's going to hit the opposite side in 2 points and form angle B sub 1 or angle B sub 2. So we have two triangles. One of them looks like the, let me go to all red here. One of them is this obtuse triangle right here. And then I'll go with this orange looking thing. The other one is this triangle right here where B sub 1 is an acute angle. So we're going to solve on this board for the angle where angle B is acute. How do you do that? Well, the law of sine says that the sine of B sub 1 is to its opposite side as the sine of 25 to its opposite. So solve B sub 108 sine of 25 over 77. So B sub 1 equals the inverse sine of whatever number that is. And here's the calculation done on Desmos. So B sub 1, the acute version, is about 36 degrees, 36.35 degrees. Now I put an arrow here to make note of the fact that when you calculate the inverse sine of this expression, your calculator gives you this number. But there's also another angle in the second quadrant that has that number as a sine. So there's a 36-degree angle here. And if we draw the other reference angle, there's a 36 degrees here. So this angle also has a sine that's whatever this number happens to be. So that's where the obtuse angle B sub 2 comes in. We'll see that on the next board. But once you've got angle B sub 1, you can find up here angle C sub 1 is 180 minus the sum of A and B sub 1. So once you've got C sub 1, you can use the law of sines again to find little c sub 1 or lowercase c sub 1. And that would be c sub 1 is the sine of big C sub 1 as 77 is the sine of 25. There's your calculation for this C sub 1. It looks like it's about 160. Do a double check and make sure the longest side is opposite the longest angle and the smallest side is opposite the smallest angle. And that looks to be the case. So that's probably good. Once you get to this board, we found that B sub 2 is 180 minus B sub 1. So the obtuse version of B is 143 degrees. I'll let you take notes of how you finish solving for the rest of this triangle. There you go. Law of sines to solve a triangle that actually has two triangles.